Alright guys, so we're going to continue on with our next lesson in Unit 3. We're going to talk about proving lines parallel. Alright, this is going to harken back to what we talked about on Monday and Tuesday. It's going to use those relationships you talked about, those correspondings, those alternate interiors, those alternate exteriors, same side interiors, same side exteriors. It's going to reference all those again, but now we're going to do things backwards. What I mean by that is you're going to be given some information about two angles, and you have to decide if the lines are parallel. So let me just show you what I'm talking about. First, we got to talk about converse. And no, it's not the shoe brand. If you see the word converse, it takes a theorem and writes it backwards. Okay? So, let me show you what I'm talking about. So, this corresponding angles postulate. Monday, we said that if two lines and a no. It says if two lines are parallel, I'm saying this wrong, but something to the effect of if two lines are parallel, then the corresponding angles are congruent. That's roughly what it says. I don't know what it says verbatim, but we're taking that theorem and turning it around. And now we're saying if two lines and a transversal make corresponding angles that are congruent, then the two lines are parallel. So in our picture, if angle 1 and angle 2 are congruent, those are correspondings, and so those lines L and M have to be parallel. All right? With alternate interior angles, it says, the converse says, if two lines and a transversal form alternate interior angles that are congruent, then the two lines are parallel. So in this diagram, if angle 1 and angle 2 are congruent, then the lines L and M have to be parallel. And now for same side interiors, if two lines in a transversal form same side interior angles that are congruent, not congruent, if they're supplementary, means to add to 180, then the two lines are parallel. So if angle 2 and angle 4, you add those together and you get 180, that means L and M have to be parallel. And now for alternate exterior angles, says if two lines in a transversal make some alternate exterior angles that are congruent, then the two lines have to be congruent. So if angle 1 and angle 2 are congruent, then lines A and B are parallel. And finally, if two lines in a transversal form same side exterior angles that are supplementary, then the two lines are parallel. So in our diagram, if angle 1 and angle 3 add to 180 degrees, then the lines A and B are parallel. Okay, it's taking what you did on Monday and Tuesday and reversing it. All right. So before we get into the problems, let me give you a couple of steps you'll want to do. So number one is you want to decide or pick your transversal. You want to see if your if your two angles are near a transversal, because that will help you. So step 2, you'll have to decide on the pair relationship. You'll have to decide if they're corresponding, if they're alternate exterior, alternate interior, alternate same side interior, same side exterior. You'll pick one of those 5. And then step 3, we're going to ask ourselves, does the info match? So last thing is if If yes, the lines are parallel. If no, the lines are not parallel. Okay, so let's put this in action. Let's look at some. So we're going to look, we got this image over here. It's just 4 intersecting lines with some labeled angles and the intersection points labeled. And we've got some information over here. We're going to use this information to see if we can determine if any two lines are parallel. Okay? So we're going to say angle 1 is congruent to angle 2. So angle 1 and angle 2. Let's decide us on a transversal. Are those two angles near a single line? Yes, they are. They are right here. So that is going to be our transversal line. Okay? So now we know it's a transversal line. We're going to have to crick our necks a little bit and look at the other two lines. What kind of relationship would those two angles have? It looks to me like they would be alternate interior angles. You say, how do you know that, Mr. T? Well, they're on different sides of this transversal line, and they're caught inside this line CK and ED. They're inside those two lines. Okay, so I think they're alternate interior angles. So let's go back and look at our information. We're saying they are congruent. We know that the alternate interior angles are congruent. So for step 3, our information matches. Okay? So now, these are parallel. Okay? We've picked us a transversal. We have alternate interior angles. That information matches what we were given. Angle 1 is congruent to angle 2 because alternate interior angles are congruent. And so we're going to say our lines are parallel. We're going to say ED is parallel to CK. And I forgot my arrows. Please remember when you're writing lines like this, you use 2 points and then draw a little line on top. So the lines ED and CK are parallel. How do we know that? What's their justification? We used the converse of alternate interior angles theorem. I know that's a lot to write out, but you've got to say all of that. I have to see converse and then the specific theorem or postulate. All right. Let's do a couple more. Number 2, B. We are saying that angle 3 is congruent to angle 4. So let's find those. So step 1, let's decide us a transversal. It looks to me like that would be a transversal because they're both next to that line or near it. And what kind of relationship would those two have? It looks to me like we're talking about a corresponding angles situation because angle 3 is in the top left of this upper neighborhood. Angle 4 is in the top left of this lower neighborhood. So it looks like we've got corresponding angles. Let's keep that on our minds. What's the information we were given? We said angle 3 is congruent to angle 4. Does that match our suspected relationship pair of correspondings? Yes, it does. We know corresponding angles are congruent. So now we can say, if this is our transversal, then our parallel lines have to go the other way. So we're going to say line EC is parallel to line DK. Okay? If this is our transversal, then our parallel lines have to be those two. What's our justification for that? We use the converse of the corresponding angles postulate. Okay? Because we decided a transversal. We know these two are correspondings, and we know they're congruent because of the information given. So we can use that converse of the postulate to say that line EC is parallel to DK. All right, so let me get rid of this very carefully because I don't want to erase. All right, let's look at letter C. Angle 1 is supplementary to angle 3. So let's look. So first thing we need to do is we need to pick a transversal. If these things are parallel, there should be one single line that both those angles are on. And so we sit and stare for a little bit. And you're probably thinking, Mr. T, I can't find one line they're both on. Well, I can't either. Angle 1 is down here, and angle 3 is up here. There's not one line that's on both of them. What do? We can't decide a transversal, so we can't even say they're parallel. So we can just say not parallel. That could be a possibility. I mean, it just depends on what information you're given. I'm going to switch this last one to be angle 2. So now we're going to look at that angle 2 is congruent to angle 3. Okay? So we want to see if that information is enough to prove that some lines are parallel. So we can pick a transversal because this one right here. Okay? What relationship would those have? Angle 2 and angle 3. It looks to me we're on the same side of our transversal, and we're outside these two lines right here. So based on their locations to the transversal, this is a same side exterior angle situation. Okay? So we got to think back to Monday and Tuesday. What was the relationship between same side exterior angles? And we said they're supplementary, which means they add to 180 degrees. Is that the same thing as saying they're congruent? No, it's not. All right? This information does not match our relationship. Okay, so these would not be parallel. Let's see if we have to justify. If we wanted to justify, we would use the converse of the same side exterior angle theorem. Okay? So be aware. Sometimes it might work out like A and B did, and sometimes you can't say they're parallel. It just all depends on what information you're given and what the relationship is of the two angles we're talking about in the picture. All right. Which lines or segments are parallel? Justify your answer. So this time we're just given two angles. We have to see, is that enough to say that some segments are congruent or lines are parallel? I said congruent, I meant parallel. I'm so sorry. We got an angle here and an angle here. So let's think for a minute. Do we have a transversal? Yeah, we do. It's right here. Those look like corresponding angles because they're in the same location in different neighborhoods. This angle right here at G is in the top left corner, and this angle here at E is in the top left corner. Okay, so if this is our transversal, what would our parallel lines be? It would have to be these lines going to this way right here. So let's name those lines. We would say whoa, line BE is parallel to line CG. How do we know that? We use the converse of corresponding angles postulate. Okay? So I still follow those steps. I picked a transversal. I noticed there were corresponding angles. And the information I was given was those little purple arcs originally that I marked green. They each had one single arc, which meant they're congruent. And so the converse says I can say lines BE and CG are parallel. Okay? Let's come over here to this. So you're thinking, there ain't no lines or segments here, Mr. T. What's wrong with you? It's just two triangles. Well, remember, you can still extend them a little bit. I think, to me, extending helps me see things. So I'm going to extend this. Because I'm thinking that's a transversal. Because I can extend that and that. And by doing that, I've picked a transversal, which was the MR. And I'm looking like I have a corresponding relationship because I have two angles that are 45. And they are in the same location in different neighborhoods. This first 45 up here at A, or at R, excuse me, at point R is on the bottom left, and this one here at A is in the bottom left. And those are the same measures, so that means they're congruent. So I'm going to say, I'm going to use segments this time because I started with triangles, so you always go back to what you started with. We started with triangles. This time we're going to say segments. So segment CA is parallel to segment HR. Why do we say that? The converse of the corresponding angles postulate says I can say that. Okay? Let's go down here. So they tell us that the measure of angle J, so I'm going to mark it, plus the measure of angle L equals 180. Now, since they equal 180, I'm going to give them two different markings, two different arcs. And based on where they're at, I'm going to extend. I think this would serve as our transversal. And then this could be our parallel segments because of the angles that were chosen. So we're talking about J right here and L right here. Those two add up to 180 degrees. So it looks to me like we've got a same side interior situation here. Now I know there's more going on here with this K and N thing. We're not even using that, so just ignore it. Because J and L are adding up to 180 degrees, I think that it's same side interiors. And I remember from earlier that the same side interior angles are supplementary. And so my information is true. So I'm going to say that the segment JO, dang it, I'm too close to that side, so it freaks out when you do that. JO is parallel to LM. And those are segments because I started with some kind of like four-sided figure. How do I know that? Converse of the same side interior angles theorem. Okay? Because these are supplementary, that I was given that, and the fact that they are same side interior angles means I can use this converse to say that those two segments are parallel. Okay? Let me separate this out. Let's come over here. So based on what I see here, this looks like, let me show you what I'm looking at. We know that angle TPQ, I'm just going to write that out for a minute. They're telling us that TPQ is congruent to angle PTS. Okay? I just wrote out what was given. So to me, it looks like, notice how the TP or PT is in both angles. That tells me that, hey, that's going to be the transversal, which means that this way could be our parallel lines. So let me mark them again because I've wrote all over it. We're talking about that right there. What's the relationship there? That's our transversal right there. What's the relationship? It looks to me like we're talking about alternate interior angles because they're inside our two major segments here, PQ and ST. And they're on different sides of this transversal line. So I know that that's alternate interior angles. What do I know about alternate interior angles? I know that they are congruent. That matches the information I was given. So everything's true, everything worked out, so I can say segment PQ is parallel to ST. And again, I used segments instead of lines because I started with this figure and they're made of segments. What's my justification for saying that segment PQ is parallel to segment ST? Converse of the alternate interior angle theorem. And yes, again, I realize that is a lot to write out. But that justification, you have to tell me everything. I need to know the converse part, and I need to know which angle relationship theorem you're talking about. All right? Now, this looks a little bit like what you did the other day. You had some algebra. The work is still the same. The work hasn't changed, but the questioning is different. So on Monday and Tuesday, you were told that, hey, you already know these are parallel. We want you to just solve for x. Okay? Now the question is, we don't necessarily know that L and M are parallel. We don't know. But what we want to find out is what would X need to be so that they are parallel? Okay, I hope I explained the difference. So you're trying to solve for X in order to make those two lines parallel. Okay, so let's look at the angles we were given. We have a 55 and this X plus 25. What's the relationship there? They look to me like they're corresponding angles. So I like to write out what their relationship is. How do you know that? Well, this 55 is in the top right corner of this upper neighborhood, and so is this x plus 25. It's in the top right corner of the neighborhood. So these are correspondings, and in order for them to be corresponding, they have to be equal. So we take x plus 25 and set it equal to 55. Okay? And the only way to make L and M parallel is that if x is 30. Right? If x was anything else but 30, the lines aren't parallel. That's what we got here on part B. So it looks like we're inside those lines L and M, and we're on different sides of this transversal. So those are alternate interior angles. What do we know about alternate interior angles? We know from Monday that they have to be congruent. They have to be the same exact thing. So in order to make L and M parallel, we've got to take 2x minus 5 and set it equal to 95. And that will give us the x value that forces the lines L and M to be parallel. So when x is 50, we can say that L and M are parallel. And if x was anything but 50, it wouldn't work. All right, I need to erase because I need room to work up above. All right, now our picture is a little bit weirder. So let's see what we're talking about. Remember what the original picture said. We want to know if we can make lines L and M be parallel. So what's the relationship we've got going on here? Well, we're outside the lines L and M, so we know we're some kind of exterior situation. And we're on different sides of our transversals, so this is an alternate exterior situation. What do we know about those kinds of angles? Well, we know they have to be congruent. So we're going to take our expressions, 3x minus 33, and set it equal to 2x plus 26, and we have to solve for x. I'm going to move the 2x at 33. X is going to be 59. All right. When x is 59, we can say L and M are parallel. If it's x is anything but 59, we can't say they're parallel. All right. Now, remember, we are trying to say if we can prove that line L and line M are parallel. So this extra line right here with this 90-degree angle on it, we're just going to ignore it. It's not needed. Let's look at what we got. So our transversal is right here. Try to make it darker. Can we find a relationship between the 105 and the 3x minus 18? So they're in different neighborhoods, but they're not in the same position, so we can't say they are corresponding. I'm thinking we're going to have to use something else to do this. And I think I'm right because we're trying to say that this line, whoops. We're trying to say L and M are parallel. So I can use corresponding angles and say that this 105 can come down right here. Okay, I know that. Ah, I see it now. All right, so because I moved that 105 down here, we're going to have to use a linear pair situation to make this work. You're like, well, where's that linear pair coming from, Mr. T? Why'd you throw that at us? Well, look at what we did. I moved 105 down here because I can do that. I know they're corresponding. And if you start this 105 and this other expression, if you were to draw that, that's a half circle, guys. And half a circle is 180 degrees. So we know that 105 plus this angle gives us 180. So we're going to say 3x minus 18 plus 105 equals 180. You're in a roundabout way, you're using that converse of same side exterior, same side interior concept. Okay. We need to combine like terms. What's 105 subtract 18? Hang on, I can do this. 87. And now we subtract 87. So we get 3x to equal 93. 93. X is 31. All right. Sorry that took a minute. I had to think about the relationship first, and then I did the math in my head, so that took a hot second. But anyway, the point I'm wanting to show you is sometimes you might have to use more than one converse theorem to get your answer. So on A, B, and C, we just used one specific converse theorem to get there. This last one we kind of had to use two. I used corresponding to move the 105 down, and then I knew that 105 plus 3x minus 18 would equal 180. So I used a linear pair situation there. Okay, I think that's all I have, so let's see what your homework is. Now I did something a little different for this homework. Instead of actual paper assignment, it's all on a Google form. So your homework is just answer all the questions on the Google form. And as always, if you need help or you're stuck and you don't know what to do, let me know, and I'm more than happy to help you.